welcome back to The Explainer. Today, we're tackling the ultimate beast for us AI builders, successfully shipping the Module 2 Capstone. Look, we all know the thrill of throwing together a quick, messy prototype, right? It's super satisfying to wire up an API, fire off a prompt, and watch some clever text pop out. But today, we're leaving that behind. We are shifting from sketching out those neat, fragile little ideas to constructing a robust, builder-grade tool that solves a real, messy problem. We're going to unpack exactly how to take all these complex concepts you've been learning and converge them into one finished, rock-solid piece of work that you'll actually keep using long after this build is over. Here is our blueprint for today. We'll be covering the Module 2 Capstone, planning before you code, picking your project template, the 6-stage build process, and finally, avoiding common builder pitfalls. Let's jump right in.
All right, Section 1, the Module 2 Capstone. We are officially shifting from prototypes to builder-grade tools.
Remember the Module 1 Capstone? That was basically all about the vibes. You ran your automation on a single input. If it looked generally correct, you gave it a thumbs up, and you could realistically knock the whole thing out in an afternoon. Module 2 is a totally different ballgame. You're now building a system designed to run on a real, unpredictable workload. It's an 8 to 15-hour commitment, heavily paced over 2 weeks, because integrated systems just take longer to construct and debug. The new baseline here is trust. You're building something robust enough that you can step away and trust it to handle your actual daily workflows without holding its hand.
Now, to actually pass this challenge, it's not just about pushing your code to GitHub. You have to produce 5 very specific artifacts. Yes, working code is on the list, but you also need a 1 to 2 page architecture document, a log of your significant decisions, concrete evaluation data, and, this is huge, a broken edges log detailing your failure modes. Why does this broken edges log matter so much? Because in AI development, failures aren't just bugs, they are data. They show you exactly where your model's reasoning falls apart. If you wait until day 14 to document these, you'll just end up making up post hoc justifications instead of capturing your honest real-time reasoning. So capture these artifacts as you build.
Moving to Section 2, Plan Before You Code, specifically looking at the 8-question decision architecture. I know your fingers are probably itching to open your IDE right now. It feels productive to just start typing. Resist that urge. You need to spend a good 60 to 90 minutes planning your answers to 8 crucial questions first. The discipline of actually writing these answers down in plain English is literally the only way to avoid ad hoc, chaotic building. Think of it like measuring twice before you cut once. This upfront investment is going to save you from having to completely tear down your architecture on day 5 just because you realized your foundation was fundamentally flawed. So one of the most critical questions you'll answer in this planning phase is exactly which skills you're integrating. You have to pick at least 2 out of 3: open weight strategy, source-grounded retrieval, or reasoning agent orchestration. And you need to deliberately state why the ones you chose are the perfect fit for your problem. But here's the catch. If you only pick 2, you have to write down exactly why your problem doesn't need the third one. Consciously excluding a skill is just as important as including one. It proves you're actually engineering a targeted solution, not just throwing every shiny new AI tool at the wall to see what sticks. You've got to define the exact boundaries of your tool before you write a single line of Python. First up, a plain language problem statement. Keep it so simple an outsider gets it instantly, like triage GitHub issues for engineers. Next, what is the exact trigger that starts a run, and what's the specific output that ends it? And finally, you absolutely must map out your models. Which model is your cheap, incredibly fast workhorse for bulk tasks like basic routing, and which expensive frontier model is your heavy-duty reasoning brain? If you send every basic query to a top-tier frontier model, you're going to blow your API budget in a single afternoon. Planning this routing now guarantees your tool is actually sustainable. Let's hit Section 3. Pick your project template. We've got 5 blueprints here to get you started. If you don't already have a burning problem you want to solve, no worries. The first template is an absolute classic, the Codebase Q&A agent. This beautifully integrates RAG with reasoning agents. Instead of a basic dumb semantic search, the agent actually decides what to retrieve. It actively uses file searches and grep commands to gather context, and then it produces verifiable answers with exact file and line citations right from your code. It's super practical and will save you countless hours of manually digging through a new codebase. We also have 4 other killer templates. You could build a domain research assistant, a customer support agent that pulls from customer history, a specialized workflow agent for stuff like code review, or even an automated personal intelligence system for your feeds and emails. But listen to me very carefully on this rule. Pick one. The absolute fastest way to fail this capstone is trying to combine them into some giant mega system. Keep your scope ruthlessly tight. All right, Section 4, the 6-stage build process. This is your pacing map for the next 14 days. This timeline maps out your 15-hour budget perfectly. Day 1 is purely specification, nailing down those 8 questions. Days 2 and 3 are for building your foundational pieces in total isolation, like getting your RAG index or your agent loop working alone. Look, pacing is absolutely crucial here. Sleeping on a problem is a highly valid engineering tactic. Bugs that completely stump you during a marathon sprint on day 1 will be glaringly obvious when you look at them fresh on day 4. Follow this map, avoid the burnout, and keep your logic sharp. Welcome to Stage 3 on days 4 and 5. Honestly, this is the abyss. This is where you wire your isolated parts together, and it's where all the nasty integration bugs live. You're going to see tools returning data the agent completely misunderstands. You'll have RAG pulling back so much context it entirely blows up your token limit. Or worse, your agent might get stuck in an infinite loop that quietly maxes out your API credit card while you're grabbing a coffee. You'll have to tightly tune how these reasoning models behave. And don't forget, every time you hit one of these walls, log it in that broken edges doc. By stage 4, the vibe check is officially over. You must replace vibes with hard data. You need to set up an evaluation harness with 10 or more representative tasks. And I'm not talking about softball, perfectly formatted test questions. I mean the real-world messy inputs your tool is actually going to face. Does your agent actually succeed? What's the latency? What's the exact cost per run? Getting these baseline numbers before you start iterating is what defines your personal threshold for good enough to ship. Finally, Section 5, avoiding common builder pitfalls. Let's make sure you actually pass the inspection. There are a few major traps here, but one of the most dangerous is treating model failures like traditional software bugs. When your agent makes a mistake, do not just patch your Python code and hit run again. You have to read the LLM's reasoning trace. That trace is literally the only way to see why the model made the wrong call. Did it just misinterpret the prompt, or did your retrieval tool feed it absolute garbage? Also, do not ignore the cheap workhorse pattern. If you default to a pricey frontier model for every single layer of your app, you are overpaying and drastically over-engineering. I want to highlight this quote because it brilliantly captures the single biggest danger for smart builders: overscoping. Deciding you're going to build a customer support agent, plus a code review agent, plus a research assistant all at the exact same time is a guaranteed path to failure. It's the ultimate trap. Nobody wants a massive 95% finished prototype that doesn't actually work. You want one reliable, highly focused tool that executes its job flawlessly. Ship it well, ship the variants later. Keep repeating that to yourself. Resist the urge to over-engineer. Think of it like buoyancy, the absolute smallest, simplest version that genuinely integrates these skills on a real workload is infinitely more valuable than some sprawling, heavy vision that just sinks and stays stuck on your local machine forever. Get the core logic working, measure it with hard data, document the edge cases, and ship the thing. You can always build out the fancy extra features after the course is done. So you've got the blueprint, the templates, and the pacing guide. You know exactly what builder grade means now. You understand why upfront architecture, ruthless scoping, and data-driven evaluations are non-negotiable. You aren't just tinkering with prompts anymore. You are building real AI systems. The only question left is, what specific, incredibly frustrating problem in your day-to-day life are you going to solve first? The blueprint is in your hands. Go build something amazing.